Imagine you are standing on the Yamal Peninsula in Siberia. It is one of the coldest, remotest places on Earth, a vast, flat landscape of frozen ground, or permafrost, stretching out beneath a massive, silent sky. You're bundled up, the cold air practically stinging your lungs. But then, you feel it a low, distant rumble. It doesn't sound like thunder, and it definitely isn't an earthquake. A group of local reindeer herders were here in 2014 when they first stumbled on what that sound had left behind. They walked over a rise in the tundra and just stopped. Their internal, unfiltered thought must have been something like, what on earth was that? Right in front of them was a perfectly cylindrical, enormous hole, a crater so deep you couldn't see the bottom, easily 100 feet wide, with jagged walls of ice and frozen earth. Scattered across the tundra for hundreds of feet was the evidence, chunks of soil and ice that had been violently ejected. This wasn't a slow collapse. This was a blast. This initial discovery, and the handful of others that followed, launched a massive international mystery. Why is the ground exploding in Siberia? For years, the theories flew around: meteors, military tests, even UFOs. But today, we finally have the compelling answer. And it all comes down to a potent, volatile gas hiding beneath your feet: methane. To understand these gas emission craters, you first have to understand the ground you're standing on. It's permafrost, ground that has been frozen solid for tens of thousands of years. It's essentially a giant, deep freeze container, and it is full of all sorts of ancient things, including vast amounts of natural gas, specifically methane. Now, for centuries, the cold has acted like an impenetrable seal or a heavy cap, locking this methane deep underground. But beneath the permafrost in this specific region of western Siberia, the Yamal and Gydan Peninsulas, there are immense, deep reserves of conventional natural gas. Think of it like a massive, pressurized gas tank miles below the surface, connected to the world above by a network of tiny cracks and fault lines in the bedrock. Because this region sits on these massive gas fields, methane is constantly migrating, slowly percolating upward from those deep reserves through the fault lines. It travels until it hits that frozen, impenetrable seal of permafrost. That's when the pressure starts to build. It's like blowing air into a balloon that can't stretch. The gas has nowhere to go but up, and the frozen ground is pushing back, holding it all in. The pressure on the underside of that frozen cap becomes immense. You can almost feel the ground beneath you heaving as it strains to hold the gas back. For a long time, the permafrost was thick enough to contain this pressure. But something is changing the rules of the game: climate change. This isn't just about warming the air. It's about weakening the ground. As the climate warms, the permafrost is beginning to thaw, especially along the surface. This creates new lakes and thaw zones, which allow water to seep down and weaken the frozen seal right where those deep methane pathways are focused. The frozen cap becomes thinner and less rigid. Imagine that high-pressure balloon again. It was strong, but now you've started to poke holes in its surface. That massive pressure, which has been building for centuries, suddenly finds a weak point when the pressure from the trapped methane exceeds the strength of the now thinning permafrost cap. The result is not a leak. It's an eruption. Scientists call it a gas blowout. The methane bursts out with violent, explosive force, ejecting hundreds of tons of rock and ice high into the air. The resulting hole is the crater you see on the surface. When researchers finally got down to study the first crater, their skin must have been tight with shock. The debris pile surrounding the massive hole told the whole story. This wasn't a gentle process. It was a geological bomb going off. So, these craters are a unique phenomenon. A perfect storm that requires two things: deep-seated natural gas reserves and a weakening permafrost cap due to warming. This is why you only see them in western Siberia and not, say, in Alaska or Canada. But here is the most concerning part: the feedback loop. Methane is a far more potent greenhouse gas than carbon dioxide. It's up to 25 times more effective at trapping heat over a 100-year period. Every single one of these explosive events vents a massive, uncontrolled dose of potent greenhouse gas directly into the atmosphere. This release speeds up global warming, which in turn causes more permafrost to weaken and thaw, which then sets the stage for more explosions. It's a terrifying runaway cycle where the very warming we cause is creating the conditions for the Earth to violently expel more of the gases that cause that warming. Researchers are racing to map new sites. They know that what looks like a typical small pond on satellite imagery might actually be a crater that is filled with water, a ticking time bomb of trapped gas waiting to blow. You can almost hear the pressure building in the stillness of the Arctic night, waiting for that moment when the seal finally breaks. We started this journey standing in the cold silence of the Siberian tundra, gazing into a mysterious, massive hole. Now you know the truth. These craters are not the work of meteors or aliens, but what do you think? Does knowing the science behind the blast make the mystery more or less unsettling? Let me know in the comments below. And don't forget to subscribe for more deep dives into the science shaping our world.